Today we're going to talk about special angles. So many pairs of angles have special relationships. Okay, some relationships happen because the measurements of the angle in the pair, and other relationships happen because of the positions of the angles in the pair. So, looking at some examples, the first pair is called adjacent angles. Okay, so adjacent angles are two angles that are in the same plane and they have a common vertex right here. Okay, and they have a common side, but they have no common interior points. Okay, so all of the interior points for angle 2 are only interior to angle 2. They're not interior to angle 1. Okay. Okay, so they're next to each other, but they're not like overlapping. So angle 1 and angle 2 are adjacent angles. The next pair that we need to talk about is a linear pair. A linear pair of angles is a pair of adjacent angles whose non-common sides are opposite rays. Okay, so let's look at this. They have a common vertex and they have a common side. That's what makes them adjacent. Okay, and then their non-common sides are these opposite rays. So we call them a linear pair because those non-common sides, the opposite rays, they form a line. So linear pair, right? Okay, so angle 3 and angle 4 form a linear pair. So we are going to decide whether these next angles are adjacent and a linear pair, or not adjacent. So AEB, angle AEB, and angle BED. Okay, they have a common vertex and they share ray BE. These are both adjacent and a linear pair. Okay, next, AEB and BEC. Let me do that in another color. BEC. Okay, so you can see that they share the common ray of BE, but they're not a linear pair, so these are only adjacent. Okay. AEB and DEC. Guys, you might think that these are a linear pair, but they're not because they do not have a common ray. So in order to be a linear pair, they also have to be adjacent, and these are not adjacent. Okay, so these are not anything. Not adjacent. Okay. Angle 5 and angle 6. Okay, so they share a common ray, and their non-common sides are opposite rays. So these are both adjacent and they form a linear pair. Okay, angle 7 and angle TPU. TPU. Okay, they share a common ray and have a common vertex, but they do not form a linear pair, so these are only adjacent. Okay. Angle 7 and angle 8. Okay, this looks kind of like the picture like right above it. Okay, these have a common endpoint and have non-common sides that are opposite rays, but they don't share a common side, so these are not adjacent at all. Okay, flip it. Okay, the next special pair of relationships that we're going to talk about are complementary and supplementary angles. Okay, complementary. Now, notice it's an E. It's not like compliment, like I'm saying sweet things to you. It's like they go well together, like that hat complements that coat. Complementary angles are two angles whose measures have a sum of 90 degrees. Okay, so if I look over here at my little batch of angles, I want to find a pair that adds up to 90. And I see that 37 degrees plus 53 degrees adds up to 90 degrees. So angle A and angle B are complementary. Notice that they don't have to be touching each other to be complementary. They can be floating around, okay? Next, supplementary. These are two angles whose measures have a sum of 180 degrees. So if I look at my little batch of angles, okay, I can see that 127 degrees plus 53 degrees gives me 180 degrees. So I know that A and C, angle A and C are supplementary. Again, they don't have to be touching each other. They can be floating around. Let's go back for 2 seconds. We're going to add something to a linear pair. Okay, so a linear pair of angles. Guess what a linear pair have their measures add up to? 180. So all linear pairs are supplementary. Please write that down. All linear pairs are supplementary. Now this is important. Not all supplementary angles are linear pairs. You can be supplementary without being a linear pair. like the ones that we just did on the back. They're supplementary, but they're like floating in space, okay? They're not adjacent, right? So you can think of it like this. Here's all the supplementary angles, and here's all of the linear pairs. All linear pairs are supplementary, but there are supplementary angles that are not linear pairs. Okay, flip back. All right, we have to find the measure for each of the following. Oh, I'm going to need a calculator. Okay, so complement means I'm adding up to 90 degrees. So if I'm finding the complement of f, don't I just do 90 minus 59? Whoops, I wrote 56. Okay, I feel like it's 31, but I'm having the kind of day where we're going to check me. It's 31 degrees. Okay, now we need the supplement of f. So that's going to be 180 degrees minus 59 degrees. Okay, I got 121 degrees. All right. So now I've got a big old angle G. Can I add anything? I mean, it would have to be a negative, right? But that's not really what it means. So we're going to say that this doesn't really have a complement. Okay, so for a supplement, we just do the same thing. We're going to do 180 degrees minus 116.5 degrees. $63.5 degrees. Okay, that's not bad. Easy. I can handle that. Okay, now vertical angles. This is something new. We haven't talked about this yet. Vertical angles are two non-adjacent angles formed by two intersecting lines. Okay? So, you can see this is one of the lines, and this is one of the lines. Now, the vertical angles are the ones that are opposite each other. So, angle 1 and angle 3 are vertical angles. Okay, as are angle 2 and angle 4. Okay, so on example 3, we have to find the pairs of vertical angles. So we're not going to look over at this side right now. We're just going to look at the left side. I see angle 1 and angle 7. So angle 1 and angle 7. Now look at those. Do you notice anything about them? I look at angle 2 and angle 6. Angle 2 and angle 6. Okay, so that was one pair of intersecting lines. Now we're going to look over here at this pair. Okay, so I have angle 3, and its vertical angle buddy is angle 9. And then last, we have angle 5 and angle 8. Now, I'm going to ask again, do you notice anything funny about these measures? Don't the vertical angles kind of look like they have the same form and size? Okay, that's because they're congruent. Okay, so if you want, you can go back in and instead of these little ands, you can write congruent between each of these. Okay, angle 1 is congruent to angle 7. Okay, angle 2 is congruent to angle 6. Angle 3 is congruent to angle 9, and angle 5 is congruent to angle 8. Okay, we actually have a theorem that says this. Now, a theorem is a statement that can be proved true. A theorem is a statement that can be proved true or proven true. Would probably be grammatically correct. Okay. So the nuts and bolts of proving it is, look at this. If 1 and 6 have to add up to 180, okay, so do 1 and 2. So 1 is already equal to itself. So 2 and 6 have to have the same measure to add up to 180 if you're combining them with 1. That's essentially how the proof goes. Okay. All right, if two angles are vertical angles, then they are congruent. Okay, so you can see that this angle and this angle are vertical angles. So I'm coding them as congruent. Their measures are equal. So that means I can use the vertical angle theorem and write an equation to solve for my x. So 5x has to equal 2x plus 24. I subtract 2x from both sides, and we get 3x is 24. Divide both sides by 3, and I get x is 8. Thank you very much, vertical angle theorem. Is that the end? That was the end. That was a quick one, relatively speaking.